Okay, so we're going to go try to go as quickly as we can over the May 27th sun measurements that I did throughout the day. So real quick, this is the path of the sun that over the flat Earth as per where it is in relation to the northern tropic. It's almost at the northern tropic. So this is about where the sun is right now. So that's where I put it on the flat Earth. And then all of these lines here are representing the azimuth angle or the compass heading of where the sun was at each hour, starting from 7:30 in the morning and ending at 6:30 at night. So this is what you're going to see from a top-down view on the flat Earth. So now going into one of the issues here is that we do notice that when we measure this out, that the sun is not maintaining a 15 degree per hour path, right? So there's an issue because right here is 15 degrees, and you can tell that the sun is actually going faster than 15 degrees per hour at this area. Now again, this is supposedly getting closer and closer to the longest day of the year, but it seems to be going faster than it should be on the flat Earth. Okay, so now we're going to switch over into the elevation angles. So the elevation angles are what is shown here of how high the sun was in the sky each hour of the day. And these two are kind of weird, not 100% sure what's going on with the 11:30 and 2:30 mark. But you'll notice that it kind of mirrors itself in the afternoon and morning. So if you took this and then this, you will notice that the elevations kind of match each other every hour, like so. But now it comes up with this pattern here, this looping pattern, and you can tell that there initially is going to be a really big problem with this angle as to the flat Earth. Now what I'm doing here is I'm adding February 21st and February 17th along with March 18th measurements as well. And every time that I've performed these measurements throughout the day on these days, they're all forming the same pattern. So perspective's not going to really fix any of these issues, right? So there's something going on here. So the only way to really rectify this is to actually break one of the flat Earth rules and bring the sun out further from the flat plane. And if you notice, if we look at it from this is a 75 degree angle, and so from this point of view, you could see that the sun makes really close to a 75 degree angle. Now these measurements are a little bit off, probably from the really high-end instruments. I'm using a compass and a speed square, but they are within usually 2 to 3 degrees of what I find online. But this is what a 75 degree angle would look like, and if we just pulled each of those suns outward, we would notice now we're making the shape of a circle. So this is the path that we can keep the suns on and still maintain all of the measurements correctly. And if we pulled all those and we put the sun out there, we would notice that the sun would actually create a circle. So a circular orbit. But again, it can't make this circular orbit and be local. So you're going to have to break a rule here to fix one of the problems with the horizon. Is you're going to have to break one of the rules is that the sun is local. But again, there's all sorts of issues here because as I'm setting down here, sun is rising in Australia. So again, another big problem is we just do not observe the sun acting this way. Okay, now let's use Blender to animate this. So we're putting the sun in the position that it was in Fusion 360. We have verified the elevation angle, or the max elevation angle of that day is at 75 degrees. So we're going to let it spin around the flat Earth. Just like it was showing in Fusion. Again, just a little bit of light just to kind of simulate light. So if we were to go back into our first person view and watch the sun, this is what the sun is doing. So the sun's not even doing what it should be doing according to our observed measurements on May 19th. So this is what the sun should be doing in a 24-hour period, maintaining a constant elevation angle. As you can see, it does get bigger and then gets smaller as it moves away from us, but it is not observed on that day as well. So a little background as to how I do these observations is, one, I'll take solar picture of the sun every hour, and then what I'm doing is I'm also taking elevation angles from a level speed square and drawing a line from the sun into the speed square, or basically from the speed square point of zero angle up to the sun, and that's where we're getting our elevation angles, and then using the compass to get our azimuthal or compass headings from. So unfortunately, the only way that we're going to actually be able to simulate reality on a flat Earth is to turn this sun into, instead of spinning in this rotation, we're going to have to do it in this rotation at 75 degrees. But again, that breaks a lot of other issues on the flat Earth. So there's that, and if anybody has any questions, let me know, or if you want to try to do this observation yourself, let me know. But I appreciate you watching, and you guys have a great day.